Hello and welcome to the Advent of Code 2021 in Python, Day 3, Part 1. The exercise today gives us a list of numbers in a binary format, and what we have to do is to go through this list and determine for each position of every digit what is the most and least bit. So for example, in this case we count that the first number has a 0 in the first position, the second number has a 1 in the first position, the third number has a 1 in the third position, and we count how many times at the first position we have a 0 and a 1. Then we do the same for the second position, the third position, and so on. And we determine how common is a 1 or a 0 for each position. And we have to determine what is the binary number that we build by taking the most common bit for each position. And the same way we have to determine what is the number that we get when we get least common number for each position. And then we have to convert this number to decimal, multiply them, and that's the answer to our problem. So let's start by copying the problem input. I write it here. It is day03.txt, and this is my input. As you can see, those are numbers of 12 binary digits, and we have 1000 numbers in this case. And now let's write the code for this exercise. The first thing we have to do is to go through all the numbers, so the usual incipit here. Part 1. Again, I have to open the file as usual. I open the input, which is input/day03.txt as fr, and I pass it to part 1. What do we do in this function? We first have to go through the lines, so for line in f. Now for every line we have to split the binary value that we find in the string into zeros as one and ones, and essentially keep a count of how many times we found a 0 and a 1 at a given position in the whole file. So let's create two variables before we cycle that we contain the count of the zeros and the ones. So we call them zeros and ones. Actually, a thing that we can do, a small improvement, is that we do not really need to keep two separate counts, because we know that every digit that we found is either 0 or 1. There are no other alternatives, so we can just count the ones. And the ones, it will be a list. How many digits are there? There are 0 multiplied by 12. This operation is simply a way to specify that I want to create a list that is this thing multiplied by 12, so repeated 12 times. If you run a Python terminal, you can see that this operation will give you a list of 12 elements. Now for each element in this line, I go through it. So I want to go through all the digits in over position. So for digit in line, notice that line is a string, so iterating over a string simply gives me the digits one by one as a character. I want to say that I want to get whether this digit is 1 or 0, and if it's 1, I increase the corresponding counter in the ones array, which is just the count of the ones. The problem is that this cycle alone doesn't tell me, it gives me the digit, but doesn't give me where this digit is. So I have to use enumerate. Enumerate is an helper in Python that simply goes through an iterator, it wraps an iterator, or any object that is iterable, and gives me back the index together with the element. So instead of just getting a digit, I will get the index at which I am and the digit. Now I say that if digit equal 1, so this digit is a 1, and notice that this is a string, then I have to increment the corresponding value into the counter array. So the corresponding element is increased by 1. This time 1 is the increase of the count. Once this is done, once we contain the amount of 1 that I found at any position in the given point. In fact, I can print it, and I can already run this code just to get an idea of what I'm doing. So I do Python 3 advent 2021 day 03.py, and I did a syntax error. This is the result, so it's the 12 count of how many times I found a 1 in this position. Now what I want to do is to build the count of the most frequent element. Another thing that is missing here is that I didn't count how many numbers I saw in this iteration. So we know that there are 1000 because we created the file, but if we want to make this program flexible, we should instead count them. So we can simply keep a total count. So I say count equal 0, and for every line I increase the count. There are many other ways. Now, another thing that you may observe is that once is initialized to 12 elements. It's a bit ugly that we made our program flexible in regard to the lines, but not to the number of digits. There is no reason to have it hard-coded in our program. So what to do instead is we declare once as none initially, and then in the cycle, when we observe a line, we say that, okay, if once is none, so if we never saw any line, we initialize once to the length of the line itself. So length of line, which means that the first time we see a line, we initialize the value of once. So it doesn't matter how many elements we have in the file, how many lines we have, as long as they have this structure, our program will work. So I run again to see that it actually works. I didn't do print, of course, so print once. I should get exactly the same result. And here it is. There is just a problem, which is that the line contains the new line character, and I want to ignore it. So what I do is I do the length -1. Why? Because one of the elements is the new line character. And here we go. Now, now I just have to build the binary digit which corresponds to the most common bit. So essentially I want to say that for every element of a sequence, when the value is greater than the half, then I want to keep it, otherwise I keep at 0. So I just say that so let's say that I think the program calls these values, what's the name, epsilon, gamma and epsilon, where epsilon, so gamma is the most common bit and epsilon is the least common. So one is basically the opposite of the other. Gamma is equal initially to an empty string. Epsilon is also equal to an empty string. I could also do this. So I assign them together as a tuple. And it's not really necessary because one is the negation of the other. So every 0 in one is 1 in the other. But I just do explicitly because it's easier to follow. So I say that for every element, so every count in ones, I say that if this count is greater than count, which is the amount of lines, divided by 2, then gamma will receive a 0, I think, because 1, because gamma is the greatest, and epsilon, conversely, will receive a 0. So I just append a 1 or 0, depending on the case. Otherwise, if C is not the most common, then we say exactly the opposite. So we just copy these two lines and swap them. So it's quite trivial. Now, after this cycle, so essentially we went through all the counts. We decided what to add, whether 1 or 0, to gamma and epsilon. So basically we build them bit by bit. I will have two numbers which are actually one the complement of the other. So I print the gamma and I print epsilon, so to get an idea of what they contain. And here we go, we have two numbers in binary, and they are of 12 digits. Now what the problem is asking us is to convert them to decimal. This can be done easily in Python because the int function that we already saw, so int of gamma, can also deal with binary numbers. The only thing is that in this case we have to pass also 2. So basically we have to ask int to not consider this as a decimal, otherwise it will give us the value as if it was a normal number, a decimal number, not a binary. But with 2 we specify that we want a binary number. So essentially we exchange the two values, epsilon and gamma, with their corresponding decimal values. So now I can print them again after the conversion, and this time instead of having a string I will have a decimal number. And the problem is asking us to give the multiplication of these two values, so I print gamma multiplied by epsilon, and this should be the solution. Let's see. And that was correct. A few improvements that we can do. I just remove the print and I simply return the multiplication of gamma and epsilon. This is because in general you want your function to not print something but instead return a value, because later if you write a test or try to automate its usage, it's much better if you can be very flexible with the result of your function. And now I simply run my code again, I get the same result, but this time is being printed by the caller, so by this block of code. And this is it for part 1.